So we're now live. Let me close that guy. And did I just close it again? I closed the issue again.
You did?
I did.
Okay.
I'm in the browser tab, not the issue itself. Although that happened also to me before. Close and the comment button are way too close to each other. All right. So, all right, guys, online. So we already had like one design review on this one. This is basically the revised proposal. Let me actually share the screen so we can actually see the proposal. So based on a bunch of feedback, you updated this proposal. Do you want to walk us through like what the major changes were?
Yeah. So essentially, we had ironed out a lot of things in the last meeting, and there were suggestions that go and figure out the names and how the port will look from .NET Core to vNext and how interop will work. So I'll just walk through the code snippets and explain what they're all about. So the first data structure is the DB column, which we had spec'd out in issue 3423, and it's a bunch of getters and setters, and there's a indexer as well on this. So these properties that are present in the data structure are some of the common properties that we see in the DB columns for all the databases and hence for all the providers. And let's say if SQL wants to provide something extra and wants to expose it to the lower level libraries which do not know about SQL, then they can expose it using the getter. Can you scroll up a bit? I want to see this whole data structure. Yeah. So that's the accessor for it, the indexer, which through which we can access the extra properties, which may for some reason be needed by the lower levels. But this is a set of common properties that we had decided upon with the community on 3423.
And what's the type of the object returned from the indexer?
It can be anything.
So is that basically the data in the database?
Yeah.
Is like a binary representation of the object?
Yes. So, I mean, it depends on the database, but this is not really the data, this is the metadata about the data. So let's say that SQL has one more property to describe its columns. Let's say not in this, but let's say if it has another property which is a bool, and then it has another property which is probably a string, and then another int, which are specific to SQL database. Mm-hmm. So it can expose those using the indexer that we have, and so can Postgre or MySQL.
Yeah. So I understand that it's metadata, but when it's stored in the database, the data will be in some binary form, or it would be all strings. Because I wonder whether it would not make sense to just return a string here. And if it's an int, it's a string representation of an int, and you have to parse. Or it really does make sense to expose it as an object.
So it can be anything. How it is stored in a database is it is stored in. We see all the metadata in a view in a database, and the view has different columns which can have their own types. So they could be a bool, a string, an int, whatever the column signifies. Okay. So So ideally, it shouldn't be that I'm returning a true as a string. It should be I'm returning a true as a boolean. Yeah.
Okay. Is there, by the way, is the idea that SQL would also derive from that class?
Yes.
A column that would give you a strongly typed.
Yes.
Yes. Yeah, that makes sense.
And so that was the data structure. I'll go down to the proposal.
One question I have is like, why are they all settable? Or other way around, if they're all settable, why are they virtual?
Because two things. They're settable because this data structure can be used as is by a provider to pass around its data. So SQL may not create SQL DB column. It can use a DB column. But in case it wants to add more strong types to it, they can derive from this class.
But then the provider would implement a subtype to be able to do it, so the setters could be affected. protected, correct?
Yes.
Or should be even, because you probably don't want the consumers to be able to.
Yeah, like if the comment, for example, like say you return a read-only collection of DB column, right? You don't want people to be able to set it to true, for instance. Right?
I'll add that as a change. I'll make the setters protected in this.
And there is basically my questions recently, right? The question is whether we need to have that object is so, because at the end of the day, you will offer. I mean, you create your implementers need to create like SQL DB columns and add their own properties, right? So I thought instead of having weakly type, we just support the strongly type. Because at the end of the day, they need to check whether the DB column is a type of SQL DB column and then use the specific custom SQL DB columns.
And the other question I would have is like if you expose an indexer, it seems like you also want to expose the possible keys.
Yeah, so the default implementation is keyed on the names of these properties. So
true, but my question is, let's say I get an instance of DB column, and for diagnostic purposes, it may be useful to know which other keys are in that. Like which other property names can I access? Like how would I even know that SQL has a magic, property called foo, right? Like how would I discover that? I mean, like I would say if you give people basically key-based access mechanism, I think you want to expose the keys somehow as well.
Yeah, so
otherwise, it may be better to just remove the indexer altogether and say, well, you have to know that it is a SQL DB column cast of that type, and then, well, obviously you know all the properties at that point.
Otherwise, they need to check now, right? If I can get this property and then I do something, but if you use strongly type, then there will be no problems to.
Well, that's the other question. If the property doesn't exist, do you throw? Do you get null?
Right now, the proposal is to give a null.
And what if can some property have a value null?
Can some property have?
Let's say you have a property called default value.
Okay, so.
So they can tell the difference between it having default value versus not existing.
Not in any of these properties that we have. They except for no, there is a string which can have null value in it, which means that it doesn't exist. So if a null is returned, then it can mean two things: either it doesn't exist, or it is not supported by whatever provider you're using. Either which way is that value will never be available from the provider.
So, I don't have a strong opinion, but if you want to let people differentiate between those two cases, you may want to think how to do it.
Okay.
But maybe it's okay, and in the future, if you discover a case where you need to distinguish, then you add additional property called is available or something like this. So another thing we discussed is the setters being protected and so on and so on. But I just noticed those are virtual methods. They are not, virtual properties. They are not non-virtual properties or fields, in which case you kind of don't need setters at all, correct?
That's my question. I would say you either settle on, you have setters, in which case they're just fields essentially.
Fields,
yeah. In that case, I wouldn't make them non-virtual because it makes no sense to have them virtual. Or you have no setters and you make them virtual. I wouldn't do both. I would make a decision one way or the other. I personally would lean towards virtual with getters only, because I think the pattern that you want to basically enforce is that it has a value. The value can really never change.
Yeah, so let me just think out loud. So yes, the intention of this to be modified is only by the providers and not by the consumers or the producers. So which makes sense to not have the properties being set outside, because since the producers should only be able to set this. Now, if they are protected, the setters, if the property and the setters are protected, then they need to subclass it, right? To be able to.
Correct.
Right, but the intention is to allow DB column to be used as is without a need to subclass it.
So why are they virtual? What's the case where you want to override this property behavior?
Why? Yeah, they don't need to be virtual. Even if they're subclass, they can be accessed by the subclasses, and yeah.
Yeah, so if they are non-virtual, honestly, I understand that you would like people to be able to use it without inheriting.
Yeah.
But I think there's enormous value in just making this errors protected. It makes it very clear what the usage for the majority of customers, it will be clear that they are not supposed to be setting these values. And then there are only few people who will be implementing custom, database providers. So for them to inherit is not a big deal.
Okay, so are you suggesting that?
I would just make them non-virtual
and public headers and
protected set.
All right, and take care of storing the values internally and.
Yeah. And if because if you wanted to allow people not to inherit from this type, you would have to have a constructor, and then constructor would have to have some, take a dictionary that basically gives you a way to set all these properties during construction. Then you don't have to inherit. You just create one. You pass all the properties. Now you have an instance.
In the constructor, we send a dictionary which has all these properties set. Why would that be necessary? I don't follow.
It gives you the advantage that now you don't have to inherit from DB column, but you still preserve the property that setters are not public.
And so the dictionary can have extra values also. And are you recommending that we expose that through the indexer?
Yeah, so that's actually touching on the related question. If I use the indexer and I pass one of the existing properties, is it going to work or not?
Yes.
So all properties I can access through the indexer.
Yes.
Yeah, you see, so you could have a constructor. It just takes a dictionary.
Yeah.
It has all the values, and it initializes like a dictionary inside this object. And then the strongly typed properties are just helpers. They basically just index into the dictionary and cast the value to the right type.
So,
but
the problem I see, the reason I didn't want to get the dictionary there is to not manage the storage of how this is to be done. So let's say if you want to specialize that, you subclass it and you create your own storage and put it there. Right now, the implementation is that you switch on the property names and return the property itself. But if you want to have it more specialized or have your own storage or want to do other things with the indexer, then you initialize your own storage internally and manage it.
But you already have storage in the base type, correct?
No, there is no storage. Storage in the sense only the properties that are there, no extra dictionary.
Correct. Yeah. I thought you were saying that you would like people to be able to completely change storage for all of the properties.
No, for the indexed properties, that if they want to use a dictionary for it, so let the flexibility be on the subclass rather than us taking the onus of putting it in the base class.
So what do you use today for the?
It's a bunch of switch case statements on the existing properties, and that's what DB column, the base class, needs to expose.
Oh, because I see the base type doesn't have any
extra stuff.
Okay, I see.
So it just doesn't make sense to.
Drive type could just special case 3 and then dispatch to the base with the remainder.
Yeah. So that's why no dictionary and just indexer.
I mean, in general, the question is like how resource sensitive is this area, right? I mean, if you like I got the impression last time, like if you do this a lot during query execution, then ideally you care that DB columns are not super expensive. I don't want everybody to hold on to a dictionary that has every single value boxed or something, right?
Right.
But at the same time, I mean, it's a trade-off between flexibility and ease of use. Like personally, I think from a consumer standpoint, the same with connection string builder, where essentially everybody just deals with the strongly typed properties, but internally I think it's essentially a dictionary of key value pairs, all typed as string, I think, and then at the end you just call toString on it. But I mean, I think this one is very similar. Like it feels very much like okay, there is a the majority of things that I care about are typed, and then for the remainers I have an escape hatch. But that to me would just mean that the behavior is such that it behaves like a dictionary for the extra values, and for the remainers it behaves like a strongly typed data structure. In which case I would probably go down the path of saying, make all the fields, so make all the properties protected settable, remove virtual, and enforce that base types have to derive, and then deal with that. Because this way, I mean, everything is a strongly typed field on the object, so the overhead of this thing is as small as it possibly can be. I mean, you can potentially have a smarter data structure if you make everything virtual by saying, oh, I know the majority of fields are 0 or false or whatever, and then I only have to allocate fields for the 5 things I care. But then they can't really be virtual. The base type, they have to be abstract so that the base type doesn't allocate an actual field, and so on that point it becomes harder to version.
Yeah.
So I don't know. Like I would probably go down the as I said, make everything non-virtual, protected setter, virtual indexer, and that's it.
Okay. So virtual indexer, I'll remove the removal of virtual agreed upon and protected setters.
Okay. The only other thing I would consider is let DB column implement iDictionary of string comma object.
And it becomes a dictionary in itself.
Well, you implement the interface, right? You can still implement it the same way you do today, but you basically get the semantics that you would expect from a dictionary, which means I would probably implement a good chunk of the method explicitly, but would leave the indexer, count the keys, try get, and then you can pretty much address all the issues we just talked about.
Yeah, it's just that if I implement from iDictionary, the only method I foresee being used is the indexing or the getter or getter on the index. Because
the try get, right? I mean, at this point you get a defined behavior. If the key doesn't exist, the indexer will throw.
Yes.
If you don't want to throw, you just try get.
One concern I would have is that now implementing a custom one would be a bit more tricky.
Why?
Because you have to make sure that, for example, the count is always consistent. But now you have the dictionary implemented by the base type that doesn't know about the storage in the subtype. So somehow you have to communicate to the base type implementation of dictionary that there's additional storage. It needs to take these things into the account when it returns you the count.
The only thing you would have to do, the only 2 things that you have to have virtual is essentially try get value, and probably another method that would just give you the number, the actual keys.
What about the count?
Well, the count is the base type's number of keys plus whatever the virtual method returns as the number of keys. Because you always have 30 elements, right?
What do you mean you always have 30 elements? You can add additional storage to the subtype.
Yes.
They can be not a dictionary, they can be just two additional fields. Now you have to communicate it to the base type implementation that you have more.
My point is that the derived type, let's say the derived type adds 3 properties, right? That means the derived type knows about 3 possible keys. The base type already deals with those. Let's say this is 27. Then the total count is 30.
Okay.
And so that's easy to compute, right? It's just basically the base type knows how many it has. It calls the virtual that gives you the keys.
What about the enumerator? How would the enumerator now walk the additional fields as well, in addition to the ones that are already in the base type? Like I think basically almost every single method on the dictionary, in the dictionary implementation, somehow would have there would have to be a hook such that the subtype can communicate that it has more
So
storage.
I think the only book idea in the drive type is the keys plus the override for the getting the value. These are the only two things we need. Everything else can be handled by the base type.
But you just mentioned that the count would need to be also.
Yeah, the base type has to handle the count. So the derived type only has to override a method that says, give me the keys. So you return foo, comma, bar, comma.
Oh, so the count would always call first get keys and then call length on it.
Pretty much. Even though
that's
static.
very expensive. I don't know.
I mean,
Why do we?
I mean, saying considering from a design standpoint.
Why? So one of the reasons for this indexer is that in case an attribute from a subclass needs to be consumed by the base class, and those cases will be very specific. That it's not that you're going to be going over all the attributes and getting them and doing something. You got to know what they are. So essentially, the consumer will need to be aware of what it wants to consume. So I think the dictionary will be a bit excessive and implementing this as a dictionary.
So what I would say is, it sounds to me like then you shouldn't have an indexer, period. That's what it sounds like. Because I mean, if you're saying you have to know the type, then I would say don't have an indexer. Basically just say it's a strongly typed thing, period. If there's extra properties there on the derived type, and if you want to process them, you have to know the derived type and you have to know the properties. So that's a fine pattern to have. I think if you have a dynamic approach to get the values, I would rather say it behaves and smells and behaves like an index. And then you can also get, if you implement actually an dictionary, you get other niceties in the IDE, right? For example, if you actually hold on to a DB column in the debugger and you expand it, well, the debugger knows that it's an interface. So that's a dictionary. You get the default behavior of you see the keys, you see the values, like all the things just immediately start working, and you basically get the benefit that everything shows up, not just the properties, right? But I would also agree with you that it seems pretty heavyweight and a bit over-engineered for this particular instance, in which case I would honestly just say remove the indexer entirely.
Well, removal of indexer.
Like, what's the scenario for it? Like, if you say you already have to know the types, then why can't you just cast the derived type and access the property?
So you can, for example, make the derived type not public. That would be the scenario. I'm not saying that I have an opinion on which approach.
Although I would say that the general pattern in ADO.NET is that the providers have derivatives that are always public. I would honestly say if you have a SQL,
the idea is to not depend on the derived types libraries. So I only depend on the common, and I have something which tells me, okay, this is the entry point for your the classes that.
Don't get me wrong. I agree with that. What I'm saying is that if you look at the provider model, that's the model you have. But you can choose to just code against the common service area, but you can always drop down to the derived types if you need to, right? That will be the same pattern here. Like most of the things you expose on the base.
Yeah.
You want to especially case SQL, where you just say DB column as SQL DB column. Oh, it's awesome. Then let me access the extra field and do something smart with that.
Yeah. No. To say SQL column column as DB SQL DB column, you need to
have a
reference on system data SQL client, and hence the other providers. So that is what the indexer tries to address.
But so is it common patterns though? Like without reference to its providers.
Seems like it.
Like it.
That's one of the key points in 3423, and
so basically they have two different libraries. One just depend on the DB commons, and then someone pass it in to that DB commons.
So otherwise, you see the whole work we did on this library and this API. The first approach that have a schema generator, I don't know if you guys remember. So that could have been possible, but the first blocker here is that the consumers don't need to know about the producers.
But I think what Himo is saying is they kind of need to know in this case. To access this property, this indexer, they need to know. So you're kind of like pretending that they don't know, but they do.
Yeah, they need to know some detail about it, at least what is that property that I'm trying to access and why I should even access it if it is special to that particular whatever.
But having said that, my care level about whether we expose this property or not is low. But what I think I would recommend is, let's say you leave the property, and in the future you discover that your customers want, the number of items in the dictionary, and they need to enumerate keys and whatnot. At that point, I think you should just at least follow the same API designer's dictionary. So this type starts looking as a dictionary. And then if you realize that you have many of the dictionary methods, just implement the interface, because you can always do it in the future. You know what I mean?
Like you're saying that as an extension, if ever we have to add to the add in APIs because of customers' requirement, go the dictionary route.
Let's say you ship this type, and then customers say, "Oh, we would like to know the number of items in the dictionary." Correct?
Yeah.
Don't add a property called number of items in number of properties. Add a
I see your point.
Count, and then if you discover that you keep adding lots of members that look like dictionary, and this starts being like a dictionary, just implement the type dictionary.
So I see. So if it starts looking like a dictionary, go for the interface.
Don't invent an alternative dictionary.
Agreed. I totally agree with that. Yeah.
Yeah, what he said. He put it better than I did. All right.
Okay.
We discussed this to death.
Down on the proposal.
I'm just scanning because I haven't read it earlier yet. I see.
So this is the interface that I want to introduce. It is called IDB Column Schema Generator, and I want to keep the name tied to the column instead of the reader, because it's really getting the schema from the column, and I believe that this may be more reusable than tying it to a reader. And the method inside this is called get column schema, which returns the read-only collection of DB columns. And this is the interface which will be implemented by all the providers or DB data readers in the providers. To be able to, this is the example I've put together, that SQL Data Reader implements its subclass is DB Data Reader and also implements the interface, and hence exposes the schema using the read-only collection or the API in the interface. Now, this is what the providers need to change. They need to implement the interface and the API in there. And but to access this, the producers, they can access it through the DB Data Reader using the same method name, the same signature, which is mentioned below. Can you scroll down more? Yeah. So if I will introduce a DB Data Reader extension, which exposes static with the same name, get column schema, and takes in a single parameter, which is this DB Data Reader. And if it is an instance of the interface, we return the column schema. So otherwise, it is not implemented.
So we discussed it last time, that these changes, you can make them in .NET Core. Correct? Like you can implement the interface.
Yes.
But not in .NET Framework initially.
Yes.
So the contract, the .NET Core contract for these APIs will not have the interface implemented on the iData Reader, correct?
Not on the data reader.
Well, but SQL Data Reader show it.
Sorry?
What about SQL Data Reader?
SQL Data Reader will need to show it.
But that wouldn't work for full framework, right? Because we can't add it to full framework.
No, so
the SQL Data Reader doesn't need to have additional methods, right? You just implement the interface.
Yeah, but that's the same problem. I think what we said last time was that this type here, DB Data Reader extensions, will have two implementations. The implementation that you're showing here is essentially the .NET Core-based implementation. For the full framework version of this type, it will do the same check that you have here, But then the very next time, instead of throwing a not-implemented exception, you would go back to the old schema APIs and adapt them. So that we can provide this type out of band. So if you're running in the context of the framework, we don't have to change SQL data reader to get these APIs.
I believe that will go in the facade implementation, not in this. The partial facade implementation.
The partial facade has
the mapping
implementation.
Well, the way I think about this is, I mean, I would ignore the term facade for now. Like, I would just say there's two assemblies.
Yes.
One, both are basically have the same surface area. One implementation is for full framework, which behaves in the way I just described. The other one is on a core-based implementation, which looks exactly like that.
Yes.
So it means on the full framework implementation, SQL data reader literally doesn't implement the interface, but DB data reader extension still works because it falls back to the old schema API.
Correct.
Which means now if you look at the entire surface area of .NET of AO.NET between .NET Framework and .NET Core, it's more consistent if we don't have to expose the fact that SQL data reader on core implements the interface, because otherwise we have to introduce a new contract.
So how will SQL?
Well, I think we talked. So I just wanted to make sure. I think this design is right, but I think we need to discuss the details of how they implement it. I thought we agreed that we will ship two different contracts. We're gonna ship a contract in the existing generation that does not implement the interface, and then we're gonna ship a contract that is a new generation that does implement the interface.
Yeah, so my understanding was that we postponed that until we ref the rest. But I don't know, Eric.
Yeah, the second part we can postpone. Logically, we.
Yeah, I think the second part will be explained, so, right, in the param for Phoenix, right?
The part that you're talking about falling back is something that I envisioned would go into the facade with the partial facade, wherein the calls to the extension method will be caught and it will be implemented on top of .NET 4.5, and which falls back to the default implementation that we expose in the framework. And what compiles or builds with .NET Core is what you saw above, which will essentially throw a not implemented exception if there is no interface implementation.
No, but the thing is that, so let's say you implemented this interface on SQL data reader.
Right.
Somebody who codes to the contracts, but wants to run on .NET Framework.
Yes.
Could write a line of code that casts SQL data reader to the interface.
Yeah.
And that will fail. That will not only fail on .NET Framework, that will literally like type not found exception on .NET Framework, which is bad. It's not that the cast will fail, the type not found will, the loader will fail. So that's why I thought we talked that the contract will not have this interface implemented on this type.
Yeah.
Therefore, but implementation will have it implemented.
I mean, I think, let's step back. I think in order to get the picture here, you have to consider there's a difference between what the implementation does and what is exposed in the surface area, right? Because the idea that we have is that we say .NET Core, .NET Framework, conceptually two different platforms. Now we designed .NET Core that essentially look at the assembly identities. They 95, 98% or whatever are literally the same between full framework and .NET Core, which means if you create a class library and you say, I only target .NET Core, the amount of things you can do there are literally more or less the exact same amount of things you can do as if you were create a portable library and say, I want to target both, so that the changes are minimal. So anytime you introduce an API that is .NET Core only, that is in a context that's shared with full framework, that story basically becomes harder. Like, it's not impossible for us, but it makes it easier for people to accidentally depend on .NET Core only behavior, which now makes it very, very hard for them to share any code with full framework.
I understand these concerns. My question is that given an interface, which let's say we don't expose it in the surface area, right now I have a SQL client which needs to implement this interface which lies in data common.
So just to make it clear, the interface, you should expose it. What I'm saying is SQL data reader should not implement this interface in the contract. Because basically, if you do a cast to this interface, you can do like a straight cast to this interface. Because the metadata will tell the compiler the cast is fine because the type implements this interface. So you can just cast it.
Your recommendation?
It's going to fail because the actual implementation in .NET Framework will not have this interface implemented.
I see. So your recommendation is only in common, and okay, so that no one can try to access SQL data reader's method directly by casting it.
Yeah.
But in the .NET Framework, this implementation will be different as well.
No,
right?
that's fine. But
Right.
if someone takes out that line, return cast get column schema on a concrete type of reader, a SQL data reader, then it will fail. The type forwarding will just fail. So,
but what is the difference if the DB reader is the one who implemented?
no, don't expose it in the contract.
Don't expose it.
You
right?
need to implement it, but don't expose it in the contract. Is what
You will basically have to have two DLLs, one for the contract, one for the actual implementation, and the contract one will just not have the interface implemented.
Okay.
Which
today,
speaking, already have today.
Yeah. Just in the rep folder, you have a CS file that defines your surface area. Don't add
the type forwarding makes it really confusing.
And then second related question, I think, in the reader, you're going to have if reader is iData, DB columns, schema generator, blah, blah, blah. Else, I don't think you should throw not implemented exception. I think it's like something, what the heck is going on exception. Because this branch should never be hit. Like literally should never. Because this code will be executing only on .NET Core, and it will just succeed.
No, it can be hit. Let's say I have, so this is SQL. The example that we are talking about is SQL's DB data provider. Now, let's say we have Postgres provider, and they haven't implemented the interface. So I got to tell the consumer that this interface is not implemented by whatever provider you're trying to consume.
I see. I think I agree. Because we're not adding the interface to the base type in this generation.
Correct.
In this generation, they have to know to implement this interface. Therefore, it can be the case that they don't.
Yes.
I wonder whether we should throw not supported.
Yeah.
And then maybe even, I mean, you can basically do the write-up check yourself. You can just say, before calling this method, you can say, does the component implement this interface?
Yeah.
So this generation, the SQL data reader is the one who implemented, right? Because otherwise the SQL data reader cannot override.
Say it again.
I mean, in this time being, we're gonna stick with this, right? IDP column schema generator, which is implemented by
we're gonna do
SQL data reader, right?
SQL data reader will implement it. Yes. The contract for SQL data reader will not show it that it's implemented.
In fact, like on second thought, though, I think we should have the query API here as well, because it's pretty impossible to write yourself without knowing the difference between this. Because basically, what I just thought is like if we throw, you should have a method that says, does this guy support schema information? Which in .NET Framework, the answer is always going to be true. And on .NET Core, it's depending on what you implement the interface. And so we should probably give you that method as well.
That
so in the Portal library, I can
schema, something like that,
or has column schema or whatever, something like that, or supports column schema or.
How? Okay, I mean
in the extension.
Yeah, because basically,
how does that look in the future is something that we need to talk about then.
Basically, the idea is that you can avoid the exception by asking the question up front. The implementation is almost identical. In full framework, the answer is always return true. On the core, you just say, does this guy implement this interface? And that's it. So it's literally 2 lines of code, and they will never change.
Okay, I mean, I see your point, but if I take it forward, for example, I put this method, and now I think that when we take it back to .NET Full Framework and put in the base class this particular method, then we know that it is available.
Yes.
Then what do we do with this extension method, and what is the placeholder for this extension method? Does it also make its way into .NET Desktop, or does it just stay in core on this extension? And
I would say I would treat it the same way as the extension method, which means if you're going to replace it with a function that is on the base type, then you apply the same. Like worst case is the method will for return to return true.
Okay.
But I think the problem is, like generally speaking, if you like not supported means the onus is on you, the caller, to know when it's safe to call this API. How would you know it's safe to call without duplicating the logic of the implementation? And the only answer to that today would be if we provide you a method where you can ask, which is basically take streams, right? You can ask the stream, are you read-only? If so, well, then don't call the write methods. If you call the write methods, well, then we still not support it because you called write on a read-only stream. And that's the same idea. Like, I mean, the caller can, put the check up in the stack and then run with it, or just ignore it, and then you just still not support it at the right layer. The problem is if you throw an exception that you cannot avoid, it results in very unreliable code potentially.
But what about not implemented? I understand we throw a lot of not supported for platform support in our code, but what about not implemented exception?
Not implemented to me is almost like something you should never see in the framework. That's more like for user code when your app has been halfly written. I don't think you should ever see that.
You should, if you're throwing an exception, you should not support it.
Not supported.
Not implemented is like, oh, well, let me just now implement. Like it's the answer to non-implemented exception should be I go and I implement it.
So it's a placeholder. It's essentially a placeholder application to track problems. Okay.
In fact, when you install tools like ReSharper, they will highlight not implemented as essentially a to-do marker. So, I mean, it's not really for framework code. Okay. On the time you ship, you should not have it in there. Only messed up.
I don't know. I mean, I see your point, but I'm not quite convinced.
Just think of how you would write portable code. Like, what kind of code would you write if you were to implement, let's say, entity framework or some sort of ORM that deals with this high-level schema information? Like what you would end up writing is code like, well, I can process pretty much anything. I can do something more if you have schema information. Yeah. So how do I avoid that my code just blows up if you happen to use a .NET Core DB provider that didn't implement the interface? Do I want my code to just blow up, or do I want my code to gracefully handle that? Well, if I want my code to gracefully handle that, do you want to call a method then you just catch the exception at all the time? Or do you just say, well, I do the check up front, and then I know it's safe, and then I flip some bit, and then some other processing happens later? And that's usually why you want capability API, so you can check early if you need to, and you can avoid the exception altogether by not calling it, by knowing certain things aren't supported. Like, you really don't want a situation where people are forced to call the API to figure out whether you support something. I mean, for this case, it's not too bad because you don't have side effects, right? It's a pure thing. It gives you data back. But in some other cases, it's like, well, or, write to the stream. Well, I don't want to write to the stream. I just want to know whether I can write to the stream, right? So that's why you want to separate it usually. And that's just the pattern that we use to actually make labels.
So the pattern that I can relate to is more to do with systems that, at a particular point, a system can fail. So I check whether the system can handle the request that I'm sending it. But for here, I was just thinking that if it can be done in a different way instead of exposing a function, just thinking out loud that what happens if I say that, okay, get schema, null. I don't have any schema for you. So because if I return a null, then there's a check there, and you figure out, oh, it's null, so I don't have a schema to work with. If the schema fails, if the schema support query fails, then also there is no schema for you to work with.
Well, it's more about the discoverability of the fact that it may fail. Consider the fact that the question is, how does your code blow up? I think that's what it boils down to. So let's say you return null. Arguably, okay, now you have a way to check whether the schema is supported by just checking whether the return type is null. Now, if I write code,
or am I likely to not write that? Null is more confusing. It doesn't tell you whether it is supported or not. I was just trying to see that can I get rid of the query method altogether? So null is more confusing for sure. That was the first thing that came to my mind. It's a bad idea. So null is bad for two reasons. One is that it doesn't tell you whether it is supported or not, and if it is supported, then is the provider code malfunctioning, or it doesn't have a schema for you. So okay, so I want to spend a couple of minutes talking about what this would look like when we go back to .NET Desktop. or the full framework with this API. So what I recommend, what I have written down here is that we take the same method, put it on the base class of DB data reader, so that we can have we can add this to .NET Core when .NET Core targets that particular frame desktop which has this in the base method, this particular API, and in that case, the an app targeting .NET Core, if it is recompiled, it will be compiled against the base class. And if it is not recompiled, then all the calls will be routed through the extension method. So if the DLL is just dropped onto the new .NET Core, then it was initially compiled against the extension method. So it's still the calls are still routed through the extension method, but the extension method is then modified by us to send the calls to the base class instead of to this interface. The base class checks that if it is already an interface implementation, then I call the interface method. Otherwise, otherwise the call would anyhow go to the subclass implementation.
Personally, I wouldn't even do that. I would say that if you do our job right, you can leave the DB data reader extensions as they are today, because the behavior should be the same.
Yeah, the reason I want to modify them is because I want to put the source of truth in the base class instead of keeping the same logic in the extension. We can leave them the same, and they will continue. Actually, no. If a new type implements,
I mean, there's not much logic in that, right? All the implementations do. I guess on the .NET framework there is logic. Like the .NET framework, you translate the old schema information with the new one. Yes, you would move that to the baseline.
Yeah.
Yes. So what I would still do is, even on full framework today, like the first line in the code should be, does the reader implement this interface? If so, dispatch to that method. If not, translate. So in that sense, in the modified version, I would just do the hard cast and dispatch, or just directly call the method. Like either way, like you end up with executing the same code. So I guess the way you would do this in V2, what you would do for full framework, you would just say return reader.getColumnSchema.
Yeah. No, so coming back to the query API. So the query API, does it also make its way back into the base classes, or does it stay in the extension and that's the end of it?
Well, if we move it to the base type, right, at that point, there is no DB reader that doesn't support schema.
Correct.
In which case, I would not add the method itself I would not move the method. I would leave the method in extension method.
Yes.
And I would just implementation to say return true. Because by the time we add it, like features like this schema thing is no longer an optional thing that the provider has to implement. We always will support a schema, and the schema may be simpler unless the provider does some extra work, but we can always provide one.
Okay. So it doesn't need to go back because it is implemented by everyone now. Fair enough. Any comments on that, anyone? So we add a query method to the extension, and that's where it stays until the API moves to the base class, where it returns true for all the implementations.
Yes. So what happens on the core side? On the core side, we would let the data reader directly implement the interface. We would add a virtual method.
A DB data reader will not directly implement the interface. That will cause a lot of confusion. So now,
why would you not do that?
Okay, so I had kept the method name same so that the base class can take the IDB column schema generator.
So this is, and then This guy is the DB data reader, which this guy drives from.
Yes.
This is V1.
Yeah.
In V2, we say DB data reader implements I DB column schema generator. We also add a public virtual get schema read-only collection block here, get column schema, which basically just implements the interface, right? And in the default implementation, we do something meaningful, right? Based on the information that we have. And what that means now is, like, even if you don't change the schema data reader, nothing breaks.
But
Right?
do I need to override that?
So now that, yeah. Go ahead.
Okay. Yeah, I thought if that's the case, then the next provider need to override the get column schema.
Yeah, for the calls to go to the base classes function.
Yeah, what happens to the data, to the derived ones? We said the derived ones today should implement the interface explicitly so we can add the method to the base in V2, right?
The question is, what happens if then base type implements the interface?
Yeah, that's where the problem is.
Well, let's say it doesn't, right? Even let's say we don't implement the interface.
Yes.
That doesn't solve the problem, because the question is still, if I now write code that calls get column schema, if the provider doesn't override it, do I get meaningful behavior?
Yeah, we can put the table, the get schema table mapping to this data structure there as the base implementation. Basically, what is going to go into the extension method for .NET framework is what can go there in the base implementation, so that there is no gap. And so three things. Do you implement the interface? That's the first thing we'll check. Yes, I do. So I'll just return whatever the interface implementation is. So I don't implement it, and so I return the the data table mapped to read-only collection and give it back to the consumers.
But you don't have it in CoreFX, the data table. The V2 we don't have data table as well, right?
No, are you talking about .NET Core? This is
this is .NET Core, right?
For this .NET Core
won't have the data table.
No, it will not happen.
I guess I don't understand. So the way this works is you would basically cast the interface in the default implementation. This way you don't break the right providers.
Yeah, when you cast to an interface, well, it will call the interface.
And the way
No, I'm saying like the default implementation would use the interface as its implementation unless you override it. So basically it means moving forward, you either override the virtual or you implement the interface.
Yes.
However, that still breaks consumers that assumed that the way to get the schema information is through the interface only, because it means now if I have a provider that overrides the method, they also have to implement the interface, otherwise other components in the system will not work. So it means if we add the method, that means for eternity people have to implement the interface and override the method. Otherwise, it's still possible that certain things don't work.
But the checks will be done in the extension, right?
Nothing stops them from calling the interface directly.
Okay.
Yeah, so basically what we would have to say is that the only way to get schema information is you should never use the interface, ever. The interface is purely a communication mechanism between the extensions and the providers. And in the next version, that communication mechanism just uses a virtual method on the base. Consumers should always call the extension, so that the extension can basically say, yep, if we want to use the interface, and if we do, I just call the base.
How do we
That's just
communicate it as a mechanism instead of...
That's why I don't like it.
I don't understand. If the base type in the future, we're talking about the future, implements the interface directly, it implements and it has virtual method that is the implementation of the interface. So I don't see we have an issue. You can cast to the interface, yes, you're gonna get the virtual implementation that the base type has.
Well, I'm saying like the base type can implement the interface. That's the problem. Cannot.
Right.
Because the problem is, what's the default implementation of the add the virtual? In order, the problem that you have is in V2, you have providers that implemented the V1.
Yes.
You want those to work. Like you want a consistent role, right? So that means you're adding the virtual. So what's my default implementation going to be? My default implementation is going to be, I cast myself to the interface. If the cast succeeds, well, I call that method. If the base already implements the interface, I just keep calling myself. So I can't do that.
So we should check it, but I'm pretty sure that I checked, and I had discussions. What actually happens is the implementation of the interface in the subtype that was done a long time ago becomes an override of the virtual method on the base type. I'm not. We should verify that, but I think that's what's happening. What is happening?
Well, no. The problem is you have two things here, right? You have the interface method and you have the virtual method.
But they have to have the same signature, correct? They have the same signature.
No, but when you implement interface, you specify how you want to map them. You can either say, I implement interface explicitly, which means the vtab slot for the interface is different from that method that happens to have the same signature.
Correct.
And that is what we basically tell people to do right now on the derived providers. We tell them implement interface explicitly, so you don't have a method that is public, blah, because if we now add virtual later on, like they have no relationship.
We should check, because I do think that they will have a relationship, and we should just tell people not to implement it explicitly. Okay, I'll tell you why I think that it should all work. I remember when, in the very early days when the type system was being designed, Anders was very adamant about making things like this work. Basically, future additions of abstractions should not kind of affect subtypes that may be
interesting idea. I would almost bet $100 it doesn't work. But so what do you think? Do you think that works? I would.
Well, I mean, I know that the implementer would not be calling base, so semantically it might have different, people would complain about. Yeah. I know that we've promised in the past not to add. We've made it a compatibility contract not to add interfaces when it changes the semantic behavior. Like people get mad when we add iDisposable because we consider it competitive because of that. So they now have to call base. And in this case, it's not quite like their implementation would not be calling base because there was none. So.
Well, you would never call base, right? They think you would always either provide your own implementation or you don't provide it.
Maybe it would result in new slots.
I'm pretty sure they're just joint slots. I mean, if you're on the derived type and you implement an interface and you don't make it a virtual, it doesn't matter. This method represents a virtual slot, but it doesn't do by the fact that the method itself is virtual. It just is. They just share one slot, right? That's what the interface map in ECMA metadata does. It just maps the interface method to that method. That's all it does.
Yeah, maybe. Okay, well, we should offline do a bunch of checks and
so the experiments that we did is that we made the base class implement the interface. We made the concrete class implement the interface. The difference is that if you're implementing the interface directly, then you don't have the override keyword in there, right? And otherwise, you are actually getting that API from a virtual, which you would override. So if I don't put the override keyword and I put a method and I put another method there, then there was a complaint from the compiler about hiding a method.
Yeah.
Yeah.
So that would be source breaking, but if you just slap the override on there, does the IL change?
That I didn't check whether the IL changed or not. And the next thing is that, if I don't put the override, then whatever is the interface method that has been implemented, that was being called, though I provided a throw not supported exception in the base, that was not being called. So this is the behavior that we observed.
But in V2, in the .NET framework, will we bring the interface or we just override? I mean, we just adding the virtual methods, right? We don't need to have the interface, right?
Yeah, I think we have we have to decide what the behavior is that we want between producers and consumers in .NET Core and V2. Like, I don't think we can have it both ways. I don't think you can say providers can either override the virtual or implement the interface, and that's transparent to consumers, because that would require that somebody always implements the interface, regardless of how the provider is being implemented.
I'm still confused. The interface would be implemented on the base type.
Well, that's what I'm saying. You can't have that.
You can't do that.
So, because now imagine you have a provider. The provider basically implements the interface because it's a V1 provider.
Yes.
How would that provider work if the base type already implements the interface?
Initially, it's a new slot, and then when they recompile, it just tells them that it's hiding a method, and they add.
I have a binary from these guys.
Then it's a new slot.
Yeah, but then, but what does it mean for the consumer?
It means, well, hopefully the implementation of those two methods would be the same at some.
But that's what we're saying. I don't think that's how it works.
Whoa.
Let's say it doesn't work like that. Let's say the public interface implementation that the component has does not override the one that we add later on in the base, which I don't think is what happens. If that's not the case,
draw a diagram like which methods we are talking about, which slots.
So this is basically almost the same, right? So we have get schema, let's say, right?
Yeah.
And that's the same thing here. So this is public virtual read-only collection DB column get schema. Right? This one here is public non-virtual read-only collection of DB column, right? And they do whatever they do.
But what types are
So what do you mean? What types?
this method and this method?
This is SQL data reader.
Okay. Mm-hmm. I see.
And this is DB data reader.
This is the base.
This is the base. So the problem is if this guy doesn't implement it, if this guy, so let's say this guy doesn't implement the interface. In this case, the default implementation of the base, what it can do is it can just say, well, if you're a V2 or V1 provider, well, then you implement the interface. So I can try to cast the interface. If the cast succeeds, I can call the interface method, which means that this base will just call the derived version of this guy. The problem is if this guy also implements interface, the cast will always succeed and you end up calling yourself, which is not what you want. You basically want to say, I will call through the interface.
But in which version would the interface be added together with the virtual method?
Well,
or
either that or never, right?
Okay, so, but which one are we choosing? Because if it implements, I'm saying if it's implemented at the same time,
Yes.
well, it better do something more than just casting it to itself and calling itself. I mean, that's a pretty stupid implementation.
You would do a try cast, right? You would say if the cast succeeds.
Whether it's try or not, it's a stupid implementation. Because it's like, I'm casting, well, it will succeed. And then I'm calling the method recursively, which will create infinite recursion. Okay, nobody would write code like this.
That's what I'm saying. In the interface implementation, you can't do that. I'm saying, like, the question is, what's the behavior, what's the default implementation of this thing?
Mm-hmm.
So, and I'm saying, if you don't implement the interface, then you can do the try cast because that has a chance of succeeding. But if you do that, that means that consumers of this tag now have to have different code based on whether the provider provided the schema via the interface or by overriding the base. You can't just rely on either mechanism, right? Like you either call now this guy, which will now work for V2 providers only, or you call for the interface, which means it will work for both old and new providers because this guy does the right thing for if it implements the interface. The problem is now if we do implement the interface, then it will be transparent for the consumer because the base already does the right thing.
I understand
And then there's no way for you to dispatch to the derived version.
I think I understand now. Yeah. When I was talking about what would work, it's the matching between the slots for these methods.
Yes.
I think we can make them all match up in the future. I think it will work. What will not work is how do we implement this virtual method in V1.
I thought we're gonna have different name. Like I don't know, because so the IDB schema has different get column schema, other things, right? And then the extension will be the same name that in the virtual method. So
Extension interface and virtual method is the same.
No. So the extension methods with the future virtual method will be the same name, but the interface methods will be different names. So in that case, in your virtual method, you still can have different name, right? Which is not overriding that interface, and then you type cache, and then calling the interface methods. So it has different names, so it doesn't.
But what's the benefit then? Because that still means that the consumer has to know which names to use.
No, the benefit is the interface is only happens in the CoreFX, but in the .NET frameworks we always use virtual methods, and there is when we adding the virtual method in the future CoreFX, this won't conflict with the interface. So in the virtual implementation, it will be just the same like what is your extension is. So if the providers is implementing interface, they will call the interface, but if not, they will call the overrides.
So what about this? Instead of implementing this virtual method by doing casts and whatnot, we throw not supported exception.
Then who would call these methods ever?
Because then it basically means the subtypes have to override it to start supporting, and then it would all work.
Yeah, but then now you're creating a rift between V1 and V2. Components will not light up.
What do you mean? Oh, you mean that the extension method.
Consumers can never safely call these methods then ever, because the provider has to do the right thing. That's my concern. Like the whole point of the feature is to say, how can we provide schema information given that we can't add virtuals to .NET Framework today? And then we said, oh, that doesn't matter. We can in V2, we can just do the right thing with the virtual and things will just work. If we can't do that, I'd rather not do the feature now, postpone the feature to the point where we can add APIs to .NET Framework and then do it the right way, rather than to create something that will work for 6 months and then we add something else that we think is better, but that never really works safely because we now have 2 features.
You're saying on .NET Framework, this method will always work, correct? Is that what you're saying?
Well, it has the problem conceptually on both platforms because it's about what did the V1 provider, like which mechanism did the V1 provider use to expose schema information. On full framework, we're saying nobody does anything, and we have the old schema information that we can adapt, which is why it works. But I can totally write a new provider that uses the interface. I only use it on .NET Framework, and then I have the same problem that I have on .NET Core. Right? If I don't implement the interface, if I don't override the method now, well, if you now call the base method, then you can actually give me schema information.
All right. Well.
But what is the problem if the interface has different name than the extension? I mean, the extension will be used by the client, right?
The problem is not with the extensions. The problem is, like, the extensions are just basically a way for us to do the casting of the interface and call the method. The problem is between the provider and the consuming code that consumes schema information through the base type. Because the problem is, so we have to choose. Either we are saying a consumer will never ever call the interface methods directly. It will always call through the extension method. In which case, we can do the right thing in the extension methods. In which case, it's all fine because now it's okay. Fine, we can adapt the right things. We can do the right checks. That's fine. If we say, well, the consumer code can always say if the provider implements the interface, that's how I get schema information. I can just call the interface member.
Yeah.
Now that means in V2, if we have the virtual method, the provider has to continue to implement this interface to make that work, which is what we don't want. But unfortunately, we cannot implement the interface on the base because now we break the light up for the base type to say, well, if you're a V1 provider, I can just call through the interface to get schema information. So we can only do one of the two. Like either we make so that V1 providers will work with the V2 of the virtual, or we make it so that consumers can always cast to the interface and call the method and have it work. You cannot have.
It's like we have one interface to represent 2 different concepts.
Well, the interface essentially today is just the basically the back channel between the base type and the derived type.
But if the provider doesn't implement interface, how can they call the methods? Of course, I mean the clients will typecast that into interface, right? But it will return null because they don't implement it. But if they implement it, you can call it, right?
Yeah, but that's exactly the problem, because now, so that's what I'm saying. It depends on which contract we want to have. So if the so let's say it's a V2 provider.
Yeah.
The V2 provider overrides the base, so it can provide schema
Yeah.
information. It doesn't implement the interface, which is what we want. We don't want people to have to worry about the interface forever, right? That now means if I have a V1 provider where the virtual didn't exist, they expected to get schema information through the interface. So to do the try-cast, the interface, you cannot cast with the interface, it fails. Which now means it's inconsistent, right? The provider has schema information, but they can't get access to it because the contract has been changed between V1 and V2.
But if it is failed, they will directly use the override methods, right?
No, because it's a V1 consumer. The V1 consumer didn't have a base type to call. That's basically the problem is, if you look at versioning, right, you have a V1 provider, so a V1 consumer working with a V1 provider, a V2 provider, or you have the other way around, right? And you want both to work.
But V1, we have to use interface. V2, you have an option whether you can use interface or you can use the override methods, right?
Well, but we want, I mean, like the whole point of the base type is to say, long term, you don't have to need the interface at all, because everything in ADO.NET is done by overriding methods on the base. That's the model that we want to have. That's not the model we can do today, because we can't add the frequent virtual today, right? So we say, okay, this is a temporary measure until we add the virtual. But the problem is now, once we add the virtual, well, now you have this rift, because if you use the interfaces, you get one behavior. If you use the virtual, you get a different behavior. And you never get a world where both just play with each other, right? So that's, I think, fundamentally the problem, which is why I don't like the proposal, because it means that, well, for now, for eternity, like if you have a V2 provider and a V1 consumer the other way around, they never really talk nicely.
So, so this problem will occur if the V1, the provider doesn't implement the interface or provide an API, or override the virtual, right? Because if the base class is casting to the interface in V2, if the base class is casting to the interface and checking if the interface has been implemented, and then returns the interface implementation, where is the break there?
Sorry, say that again, like I'm not following.
In V2, we can have two kinds of providers. One who have implemented the interface, three kinds of providers. One who have implemented the interface, second who implement the virtual or override the virtual, and third who have not provided the schema at all, right? So in that case, in the base class, if we cast to the interface and return the interface schema or implementation as the first step, followed by a not supported exception, whatever the right exception is, that doesn't that work for us?
No, it does work. It just means that the base type can implement the interface, because otherwise you call yourself, right?
Yes.
Which now means that.
Why is base type's implementation of interface significant? That is the part I am missing.
Yeah, so okay, let's talk about this. If the base type doesn't implement the interface, what now happens is, if you have a consumer, that basically says, I find schema information because I'm a V1 consumer, right? In V1 there is no virtual.
Correct.
So in V1 you say, okay, I know that if you implement the interface, I can call that method and get an answer. That means that code will not work with a V2 provider unless they also implement the interface.
Yes.
So that code will not be able to access schema information.
Correct.
Which I think is unfortunate, because it now means that if you have existing code, like you basically have to change everybody in the system, right, in order to really get the virtual in place and have all the components just work.
No, I mean, so essentially we expose two methods of exposing the schema. One is via the interface and one is via the virtual, which doesn't implement the interface. Right. Or one is via DB DataReader, which doesn't implement the interface.
It's generally best. Like if you have two ways of doing things, the one, like what you basically want is you want to say, you know, I want to decouple consumers and producers, right? Producers can choose to use one or the other, it doesn't matter. And consumers can interact with those regardless of how they were implemented. That's what you want. As soon as you have a coupling where consumers and producers have to change and have to agree on the way things are, it causes versioning issues. Because if you have a V1 consumer with a V2 provider, the other way around, they get inconsistent answers. Which means if you consider an ecosystem of OIMs on the one hand side, and I don't know, like you basically just move the other way, then the problem is for us in order to like make this virtual viable, like you start with a -1,000 points. You say, oh, the design would be so much better with a virtual.
Yeah.
But now you're saying, well, but the ecosystem takes another 3 iterations to actually pick up and have everything work. Is it worth it? Or should we just say, fuck it? The only way to do it is via the interface, because then at least everybody knows how to talk to everybody else, and you don't have that rift. And that's the unfortunate thing, because it now means that whatever design we pick today is probably going to be the design we have to live with for.
Well, so that's what I was saying. I think we try to represent 2 different concepts with one interface. One way we could do it is just have, imagine initially we ship interface with method getSchemaCore, and then in the future we add a virtual method called getSchema.
Okay.
The getSchemaCore is like it's a provider interface. GetSchema is I natively support schemas. I don't need a provider. And then it will all work.
I'm not sure I understand what that proposal would change. I think what you're saying is that you are basically by name implying that consumers should never get schema information through the interface. The interface is implemented.
It will keep working.
Why would it keep working? That's the thing I don't understand.
Because if you implement the interface, you provide schema. So why would it not work ever?
No, the point is that if I expect providers to give me the schema via the interface, if the provider does implement the interface, does it mean it doesn't have schema, or does it mean I call the wrong method?
If the provider does not implement the interface,
it means it may provide schema via some other mechanism. It doesn't mean it doesn't have a schema.
Correct.
Yes, that's the rift I'm trying to fix. Because it means in V2, not many providers will implement the interface. That's the whole point. If we could get the base type to implement the interface, and the nice thing is the provider no longer has to implement the interface because the base type already satisfies that. But that will make it impossible for the base type to light up on the presence of the interface in the derived type.
But so then there's this virtual method. If you override it, you basically deciding whether you support the schema information or not, because you're changing the default behavior, which does the cast, and now you don't even have to do the cast to the interface. You just implement and provide the schema. I think it would, maybe it wouldn't be ideal, but I think it's.
I'm still not sure I understand entirely what you're saying, because I mean, it seems to me like we're just tiptoeing around the subject of what we break.
No, so look, this is what I was thinking about. No, we don't break. I don't think we break anything. So the virtual method.
Well, break may be a hard word.
Correct?
I think you just have inconsistency.
It does the cast. So far, I equals this as I. What do we call the interface? The
CSG.
Correct? And does whatever. So that's in the baseline. Now I'm a subtype, and this is my subtype.
Yes.
I implemented this interface, and I implemented getSchemaCore.
So different names,
maybe even explicitly, correct? I explicitly implemented it. Now I recompile to a new version of this base type. And I know that there's virtual method, I just override it. Well, I kind of will keep both of them consistent. I will make sure that the behavior is the same.
Yeah, that one is fine. That would just work. I don't have any problems with that.
Yeah, so what is the problem with this?
The problem is this party over here.
Which part?
The consumer.
Yeah.
Is it in the
DB data reader?
Is it in the call? The consumer for the call, or I mean for .NET frameworks, they will only have the virtual. They won't have the interface, right? Which is solve the problems. But this problem only for the call.
So they basically, I guess that's a fair point. Like, let's talk about the the consumer based on core, because in core, in V1, every provider will implement the interface.
Yeah.
Will have to implement the interface. If I make that assumption in my OR mapper and I do the cast to the IDB, blah, 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 and I do whatever magic I do with the schema information. Now let's say I'm a V2 provider, right? And I want to override the message to get rid of the interface. As soon as I do that,
you don't ever get rid of the interface.
That's exactly my point. So that means for eternity, if I want to write a provider that works with the ecosystem, I have to override the virtual and provide the interface. At which point I would say, why adding the virtual in the first place?
But for
why
the
not just say it's only via the interface, because it's a much simpler world.
but for the
You
consumer,
always have to do both anyway, then just have one.
for the consumer, it has, I don't know, ideally they should go to the extensions or to the override method. They cannot just.
That's a valid position to have. You can say like consumers should never ever do the cast because it will not work in full framework anyway.
They have to go to this.
In which case you would say this is a bogus consumer. And that's a fair argument. I'm just saying it's unfortunate because it means it totally matters how V1 code consumes schema information. If they do it via the extensions, then in V2 you can literally drop the interface, override the guy.
Dropping an interface is a breaking change. Nobody should be doing this.
Well, fair enough. But like, let's say you write a new provider. You start a provider from scratch, and you want an existing OR mapper to work with that guy. It's the same situation. Do you implement the interface and override the virtual, or do you just provide the override? I think the world we want to have is that long term, nobody ever has to implement this interface ever. They just have to override the virtual, because that's the nice thing about having a virtual. I would say if you have to do both realistically, then I would not add the virtual at all. I would just say, yep, the way you provide schemas by implementing the interface. But I think if you say, well, consumers should never call the interface directly, then I think it's fair to say, well, you never write this going away. You just call get calling schema, and that guy will do the right thing. In V1, it will literally just do the try cast, and in V2, it will say, well, I just call this guy, and then that's the end of it.
I would need to sit in front of the computer and play with it to reach more.
But this is, I mean, ultimately we'll break someone or the other, even if we create this via messaging. Yeah.
Well, we're not gonna be. We cannot break anybody. And I think if the moment you implement the interface on a provider, you will have to keep implementing it. Now, Imo pointed out what it means is that some future providers will be kind of forced to follow this pattern, despite the fact that they don't have to. That's, I wouldn't say that anybody would be broken.
I'm not contesting that part. What I'm saying is that if we say that, okay, interface is the only way to go, or if we say that, no, this extension method is the way to go to access the schema, but there's no mechanism to prevent anyone from accessing the schema using the interface. I'm not contesting that. So,
yeah, it just means that if you're breaking is the wrong word. Basically, what it means is if you write an OR mapper or if you write a provider, like you have to be able to say, well, if I want everything to work, I probably have to do both, the old way and the new way. And I think that's unfortunate. I'd rather have a world where it doesn't matter how the consumer does, it doesn't matter how the producer says. If the producer uses the old way and the consumer the new way, the other way around, they will always be able to talk to each other. And I don't think we can get to that world because because the channel differs. At some point, you're not able to dispatch across these boundaries.
Well, no, we still have the option of DB provider, the base type, never implements the interface.
Yeah, but then what I'm saying is that you can never rely on the fact that interface is the only way to get access to the schema information. Because if the provider doesn't implement the interface and override the base, you don't get access to the schema information. In which case, it matters whether you ask for the V1 mechanism or the V2 mechanism. And that's the rift that I'm trying to point out. Because you can't have it both ways. And I think it's a fair design point. It just means that I don't think our design is as clean as we originally thought it would be, but it doesn't mean that we shouldn't do it.
But what is the reason typecast it by itself? Like, what is?
Because that's how people. Yeah.
Because the interface is just have one method, right? Which is called core, and then we can put a comment. I don't know. should call the get column schema, which did properly catch and then try catch and.
Yeah, it's the same with other cases, right? I mean, the problem is you have the interface, right? The interface looks like what you want. Like, and the question is, do people understand that this is just for the providers? I mean, you can do certain things like putting in a different namespace. I don't think we have one, but you can put documentation on it and say this is for the provider. Don't do that. Use the extension method over here. But like with all things, like people don't read docs, and if they just code things up, they test it. If the code works, they ship it, and then even we told them the docs don't do it this way. Like V2.
So, honestly, there won't be that many people who implement the providers. Given that the complexities that we just discussed, I was just not at the virtual method. I would just teach the provider vendors you have to implement the interface. Interface is the way to get schemas, because at least it's clean. They need to know to do it. It's not as suddenly virtual methods show up in IntelliSense and whenever you type override, but at least it's very clean. Like once you know that you have to implement the interface, is very clean. You cannot make a mistake. When we add like virtuals and the interface, there's a potential of calling something incorrectly.
There's a lot of confusion there, Christoph. Agreed. So what happens in V next? So we just take the interface and put it in the framework, and okay, and the extension method doesn't make it to the framework though, right?
Yeah, it doesn't. The moment the interface is there,
it could, but then you couldn't. Then if this came along again, you'd have a new type.
Thanks, Eric.
So
I don't think we would put the extension method in the framework. We would put the interface in the framework.
Yes.
Because they can't change anyways. And I mean, that allows providers to do the same thing there. They can decide to go the old schema route, or they can go with the new schema route. And yes, within the framework, that will create a rift, but hopefully more people share code between core and framework, in which case it doesn't matter. And then.
So, slightly different question. So, I understand that we support PCL, but what about code compilation, code compatibility between core and framework? I assume that may never be possible, right? Because there will always be something ahead in core or ahead in.
What do you mean by compatible? I mean, we are striving for third parties being able to write code that runs on both sides of the same binary. Yes.
Same binary. So binary compatibility is what we are talking about. Okay.
For a subset.
I was wondering that do we talk about code compatibility as well? That because just with the source code compatibility, especially with respect to this extension, this will not compile on .NET Framework, even if we put the interface and not have the extension. So wanted to know what the tnet there is. So
the idea is that if you if you keep binary compatibility, even though they're strictly speaking orthogonal, binary compatibility is more like a stronger version. So if you're binary compatibility, you're obviously in most cases source compatible too.
I think you're talking about source compat if they didn't have the package that included this extension method.
Yes.
Yeah. So that's
you have to have the right packages.
Yeah.
But the moment you have the right packages, then it should be source portable.
So
it's a general problem with a system. Everything is NuGet based. If you don't have the right references, your source will not compile.
So I guess we'll need to go back and think about it a little bit more. As in, we discovered more problems with the initial discussions that we had during this meeting. So
if we don't want to bring the virtual, then the interface doesn't need to have different name, or we just put a different name in case.
Oh, the same interface.
I mean
virtual.
No, I mean the interface name.
Yeah.
At this moment, because we considering bringing the virtual, that's why it has to be different name. Get schema core, right?
What virtual?
I mean the interface name. The interface methods called get schema core, right? Which is different than what is our extension.
Yeah.
But if we decided already that we don't want to bring the virtual method in the future, then basically this interface name can have the same name with extension.
You mean the method name? Yes.
Yeah, the method name.
Yeah. The core would solve one problem, but it introduces another. It solves the problem that you can cast in this virtual method to this interface and call this method without worrying that now somebody implements another interface that has a method with the same name, and now it's infinite recursion. Basically, we have two different methods, correct?
Yeah.
So you don't create infinite recursion.
So
but it introduces the problem that Timo pointed out, that now you kind of have to implement two different methods. They have to be. You have to be very careful. They have to have the same semantics, otherwise.
And we have 3 ways to.
And there are many different ways.
Okay.
And you can make lots of mistakes.
Okay. So it just
I would honestly say that the extension method probably should match the interface method.
I would like to go with that so that at least we know that they're doing the same thing.
Because I mean, in V1 of .NET Core, whatever the version of ends up being, we basically would not add the interface to SQL Data Client in the contract, which means if you're in IntelliSense on SQL Data Reader, you will only see the extension method.
Yeah.
If you're in V2, where we actually added it on .NET Framework and the other side, well, you see that in IntelliSense, it will basically replace, quote unquote, override essentially in override resolution, the compiler will see the extension method and the interface on the specific type.
Yes.
If you actually have a SQL Data Reader, right? And if you call that method, you will now call directly passing the extension method, which is worst case just buys you some perf, which wouldn't be bad. If you have a DB data reader, you will not see the method at all, so you only see the extension method. In which case, that thing does the right thing. So I don't think there's any problem, and I think it just creates a clean IntelliSense experience because there's only ever one method to talk about, and it's either an extension method or directly on the type. All right, so that means no virtual V2. Providers will continue.
So, no base class modification at all. One interface, one extension.
One extension, yeah. Frankly, if you would get default implementations of interfaces, I think we would have a very better way of doing versioning.
Well, and also I just was thinking that.
Add duct typing while you're at it.
Yeah.
Maybe default interfaces is simpler than duct typing. But
by the way, we also just invented an idiom, I think, for how to do virtual extension methods.
yeah, I mentioned that to Imo last week that we need to we need to have like a recipe book of here are the patterns we're establishing to OOP desktop.
Yeah.
When you want to add this type of thing.
We thought extension methods are great, but you cannot make them virtual. Well, you can. You add an extension method. Inside the extension method, you cast to an interface. Then you call whatever you would do in the default implementation if the cast fails.
Yeah.
And then you provide an interface that is your virtual implementation.
Yep. And I hate to say it, but that sounds like COM. It's a managed COM. COMMO, MoCOM, whatever you want to call it, modern COM. I think the name is already taken, but yes, this is how we get in trouble. Anyway, so I think the overall APIs look good. I think it was the only contentious point we had, right? Is there anything else that you wanted to cover?
No, Imo.
Otherwise, I think
whatever we spoke about is one of the next.
Yeah, so the only other thing that came to my mind was, should we create actually a compound type, or do you think the only collection of DB column will satisfy you for eternity?
So that's what we're returning today, BA. That's what we've been returning since a long time. So they should.
You don't think you ever need something else like meta information for for example, what happens for cases where you have a query that has multiple result sets?
Yeah, that's fine. There will all be a list of DB columns.
Well, but how do I know which columns belong to which result set? Would you say you call the method after you move to the first result set, and now the column set you would return is for the second?
Yeah, it's basically on the state of the reader, the data reader, whatever. It's like a pointer. Wherever it is pointing, you're supposed to return the metadata for that particular result.
Yeah, that seems reasonable to me. I think that's pretty much all we had. Cool. Yeah, I will write this up again. I think
we'll go back and think more about it in case we see that. I mean, we have simplified it, oversimplified it, and gone back to the bare.
Honestly, I like that model more because it's simpler. It's less magic.
Yeah.
It's not necessarily as elegant as it could be, but
there's no confusion.
At least it's very easy to reason about what happens between V1 and V2 and V3 and V4. And awesome. So nobody online had any questions? I guess that either means it was too complicated to follow or we did a good job. Anything else? Otherwise,
so what do we do? Do we change after changing the proposal? Do we come back again or just change? I mean, I understand that the onus is on the owners, which is us, I guess. So
I would just write up the notes. I would send you the notes.
Yeah.
And then what I would do is I would just, if I were you, would just edit the whole issue.
Yeah.
Strip it down to what it is now and say this is what we discussed.
Okay.
Then, that's so it's more like an FYI for both of us to be on the same page. I don't think there's any major reason why we should. I mean, I wouldn't keep the old proposal around, for instance. I don't think we would go back in time and say, "Oh, let's read the original proposal again."
Yeah.
You have enough notes.
Okay.
So it works.
Anything else?
Cool. Awesome. Thanks.